Hi, my name is Drilan, and in this video we're going to learn how to make a game theory related program that we built with Java as part of a project for game theory class from University of Pristina. It's a program that its purpose is to eliminate rigorously dominated strategies and finding Nash equilibrium on a given utility matrix. So let's talk a little bit about the architecture of the project, so how classes interact with one another. A utility pair class represents a pair of values on a utility matrix for two players. A utility column class represents a column in the matrix, and the utility row class represents a row in the utility matrix. They both reference a list of utility pair objects. Utility table class represents the matrix and references a list of utility column and utility row objects. Dominated strategies are the kind of strategies that we would never want to pick because there would be another strategy that would always give us a better outcome. Here, strategy 1 rigorously dominates strategy 2 for player 1 because it always gives a better outcome no matter which strategy the second player picks. So how to eliminate these strategies? We have to compare every row with every other row and every column with every other column until we are not left with any dominated rows or columns. This is the method from utility row class that compares the row itself to another row. We compare every pair of elements of the rows, x being the outcome for player 1 of the pair I, and y being outcome for player 2 of the pair I of the row 2. If there exists a pair such that x is less or equal to y, then this means that the row does not rigorously dominate the second row, and we stop right here. And if this is not the case, then it means that the row dominates the second row and the method returns true. Now we compare every row to one another. Here we make sure that we don't compare the row to itself, and if the row I dominates the row j, then we simply delete it. We keep doing this process until we are not left with any rows and columns dominated. Now let's talk about finding Nash equilibrium. A Nash equilibrium is a pair of values of the table on which best responses for both players occur. Note that by this example we see that there can be more than one Nash equilibrium, so we have to be careful with our implementation. So we have to make a Nash equilibrium a list of utility pair objects. In our utility pair class, we have two Boolean variables br1, br2, which become true if value 1 and value 2 happen to be a best response, respectively. So a utility pair is a Nash equilibrium whenever br1 and br2 are true. To find best response on a given row, we first copied all of our row elements to a best response list. Whenever we found a value in a row that is not a best response, we removed it from best responses list, leaving us in the end a list of only best responses. An almost identical, similar method is for utility column class. We then find the best responses on every row. While we are finding best responses on columns, we also check if the best responses for the column happen to be Nash equilibriums, and if they are, we add them to a list. And we are done. Here's a demo of what our program does. In the first picture, we have given the utility matrix and asked the program to show steps on every iteration. On the second picture, we have given the utility matrix and asked the program to find our Nash equilibriums. Thanks for watching. You can find the source code in the link in the description, and if you have any questions, write us a comment below.